In this video, I will show you how we can solve Cauchy-Euler differential equation. Cauchy-Euler second order differential equation in general is in this form: x squared y double prime plus ax y prime plus by equals 0. In this video, we are talking about the Cauchy-Euler differential equations that are homogeneous. In the next video, we will talk about the non-homogeneous Cauchy-Euler differential equations. But here we suppose the right side of the equation to be 0. For solving the Cauchy-Euler differential equation, first we have to write the characteristic equation. The characteristic equation for a Cauchy-Euler differential equation is r squared plus a minus 1. Note that here in this form, a and b are constants, not functions. A and b are numbers. Plus a minus 1 r plus b equals 0. So this quadratic equation is the characteristic equation for the Cauchy-Euler differential equation. When we solve a quadratic equation, three different possibilities can happen. The first case is that when we solve this quadratic equation, we get two distinct real roots. Say those roots are r1 and r2. So let's suppose when we solve this, we get two real numbers like 4 and 10. Two real numbers, two different real numbers. If this happens, then the solution for the Cauchy-Euler differential equation, if we suppose y to be the solution, is c sub 1 x to the r1 plus c sub 2 x to the r2. So we can find the solution simply from this formula. Just plug in the numbers that you get from this quadratic equation and put them as the power of x. But when we solve the quadratic equation, it is possible that we get repeated roots, not two different real roots. So the second case is to get only one root, and suppose that root is r1. But this is a repeated root. If this happens, we get only one root instead of two different real roots. Only we get one real root. Then the solution is c1 x to the r1 plus c2 x to the again r1. But because this is repeated here, multiply this by ln of x. Or you can say ln of absolute of x. If you want to make sure x can be any real number except 0, you can put absolute ln x. But usually we write the answer in this form. The third case that can happen when we solve this quadratic equation is to get two complex roots. Say those roots are, for example, a plus, not a because we have a and b here. Let's not use a and b. Say those complex roots are alpha plus minus I beta, or beta I. It's up to you to write beta I or I beta. The order doesn't matter. But let's write it beta I. When we solve the quadratic equation, we get two complex roots in this form, then y is c. Let's put c inside the bracket. Then y equals to x to the alpha times by c sub 1 cosine of beta ln of x plus c2 sine of beta ln of x. Again, if you want, you can put absolute around x here in these formulas. but I prefer to write my answer in this form. So these are the three different cases that can happen when we solve the characteristic equation. It's possible that we get two real roots, one real root that is repeated, and the third case that can happen is to get two complex roots. And note that when we get complex root here, I means a square root of -1. Let me show you an example of Cauchy-Euler differential equation. Let us start with a simple example. For example, consider this Cauchy-Euler differential equation. X squared y double prime plus 6xy prime plus 6y equals 0. And don't forget, when you want to write the characteristic equation in this form, the coefficient of x to the 2 here must be equal 1, like here. If coefficient of x squared is any number other than 1, first make this coefficient 1 by dividing both sides of the equation by that coefficient. Let's write the characteristic equation first. The characteristic equation for this differential equation is r squared plus a. A is, compared with here, a is 6. Subtract 1 from 6, a minus 1. 6 minus 1 is 5, so plus 5r plus b. B is 6 equals 0. If we factor this, we can write it as r plus 2 times r plus 3. Or you can use quadratic formula for finding r. From this equation, r equals -2 and -3. So we have two distinct real roots. So the case 1 happened in this example. And so the solution to this differential equation, y is c1 x to the -2 plus c2 x to the -3. Note that we are using this formula because we have two distinct real roots. Let me show you another example. Consider this differential equation. X squared y double prime plus 5xy prime plus 4y equals 0. First, we write the characteristic equation. The characteristic equation is r squared plus a is 5 minus 1, a minus 1, 5 minus 1 is 4, so we have 4r plus b. B is coefficient of y, which is 4 equals 0. If you use quadratic formula, or if you factor this quadratic expression like this, if we set this bracket equals 0, r is -2. If we set the other bracket equals 0, we get the same number. So this root is a real root, but is a repeated root. And because we have a repeated root, we have to use the formula for the second case. What was the formula for the second case? We have to use this formula. c1x to the root that we get from the quadratic equation plus c2x to the root times ln of x. If we use that formula, y equals to c1x to the -2 plus c2x to the -2 ln of x. So this is the solution of this homogeneous differential equation. Now let me show you an example of the third case. Consider this differential equation. X squared y double prime plus 7xy prime plus 5y equal 0 plus 25y equal 0. First we have to write the characteristic equation. If you remember, characteristic equation is r squared plus a, which is 7, minus 1 is 6, r plus b is 25 equals 0. If you want to factor this, you will see that you cannot factor this. So you have to use quadratic formula for finding r. R equals, let me remind you the quadratic formula for solving a quadratic equation. If you have an equation like this, ax squared plus bx plus c equals 0, x is negative b plus minus square root of b squared minus 4ac over 2a. Note that here a is 1, b is 6, and c is 25. R equals to negative 6 plus minus square root of b squared, 36, minus 4 times 1 is 4 times 25 is 100 over 2. And from this r equals negative 6 plus minus 36 minus 100 is negative 64. And square root of negative 64 is actually a square root of 64 times the square root of negative 1. This equals 8, and this is I. So plus minus 8i over 2. From this r is negative 3 plus minus 4. So alpha is negative 3 and beta is 4. Let's take a look at the formula to remember the formula. This is the formula that we can use when we have complex roots. X to the alpha in our example is negative 3 and beta is 4. So x to the negative 3 times c1 cosine of 4 ln of x plus c2 sine of 4 ln of x. So based on that formula, the solution for this equation is x to the negative 3 times c1 cosine of 4 ln of x, or absolute of x, plus c2 sine of 4 ln of x. I hope by watching this video you have learned how to solve the Cauchy-Euler differential equation, the homogeneous actually Cauchy-Euler differential equation. If you like this video, please subscribe in my channel, and thank you for watching.